Okay, so if we worked 9, the real question here is, what are the intervals of this function in which water is increasing at an increasing rate? It's increasing at an increasing rate. So what does the graph look like if it's increasing at an increasing rate? Well, from left to right, the y's have to be going up, but the graph has to also be concave up. If the graph is concave down, it's increasing at a decreasing rate. Right? So think about slopes of tangent lines and what happens. So right here at the beginning, the graph is increasing. It increases between 0 and 6. But is it increasing at an increasing rate everywhere between 0 and 6? Well, it's not. If you think about it, the slopes of tangent lines, they're getting more positive, more positive, more positive, but then they start getting more negative and leveling off. So where does it switch from increasing at an increasing rate to a decreasing rate? It's at 3. You see the graph is concave up until 3 and then switches to concave down. So the first interval is from 0 to 3. Now look again, where does it start increasing again? Not until 18. The graph's going up again, and it's concave up that entire time. So it's always increasing at an increasing rate from 18 to 30. So from 0 to 3 and from 18 to 30.
No, I did that backwards.
Yes, you did. Yes, you did. So if you picked A, then you were at least aware of this, but you had it backwards. Yep. You picked the interval that was increasing at a decreasing rate. Most people picked picked D, that missed it. Where that's everywhere it's increasing. But it's not increasing at an increasing. You can see the difference there. So from reading here, these numbers, you tried to put them in here?
Yes.
Okay, well if you think about it, if I'm multiplying on the outside, what kind of transformation is that?
I thought it was
Vertical?
dilation.
Yes. Vertical stretch or compression?
Excuse me, teachers. Juniors and...
Okay, I'm back recording. Back to happy, peppy. Okay, you're right. A is a vertical stretch. So we put 5 in for A, if you want to go that route. So this is 5 times f of... Okay, what is the B?
It's not 1/2.
It is. That's the horizontal stretch and compression. And then X. And then the C is... So if you wanted to write it this way, you could. To me, this looks like jumbled mess, right? Because I still don't really know what f of x is. It's just some random f of x. Now, could try to figure out a way using this to make it work.
I plugged in -2 and 5 because it told me h of -2, so I went to -2 and 5.
So if x was -2,
Yeah, and the f was 5.
but f is not 5.
F of x is 5.
All of it used to be 5. You can't put a 5 here. So if you put a 5 here and a 2 here, does it give you... Is that how you get it?
I don't even know what I got.
So let me just try it. What'd you plug in here?
-2.
-2. This would be -1. -1 times 5 times 5 is -25. Minus 4 is -29.
Yeah, that's what I got.
And 28 was close to that. Is that right?
Yes.
I'm just. Again, I'm trying to get in y'all's mindset. And again, I might try to use this later, but that's not where my brain goes. Okay? So for me, do you guys remember when we first did the transformations and before I showed you the... remember we learned that... what was that cheat? Remember that formula that I said I didn't have a clue existed? And then we started using that formula. Remember, we did this for a whole day, and y'all hated it. And then I came back in the next day, and I had a formula that I learned. And you said, I bet you studied last night. And I said, no, I didn't study. It made sense the next time
I don't know the formula, though.
Right, I don't know it either. But I don't use the formula. Do you remember the day before how I was doing all that crazy stuff that you guys hated? Well, that's what you got to do here, pretty much. Because you've given The ordered pairs.
Yeah.
So this is what I think about. Normally, if I plugged in -2, I got out 5. Okay. It tells me the order to do the transformations. So if I do a horizontal dilation by half, horizontal is on the inside. It does the opposite from what we think it should do. So if I took -2, I'm not halving it, I am doubling it. Because it goes the opposite direction from what we think. So where does this point go to? Here. Now then this point's there. -455. Then from here, we want to stretch it by 5. So multiply the y value by 5, which is 255 times 5. That's 250, 275? Is that right? That's what I've got in my head. 275. And then it says, and then go down 4.
Oh, I see.
271. We didn't do one quite like that. That's kind of the way I was originally showing you guys how to do it, but you all hated that way. So then I just quit doing it that way, and I thought, well, they're not going to have a problem if they have to use the points. Well, there was. You had to use the points. You had to go that way. So don't hold yourself responsible for missing this one. This one was hard. Like, after I got done grading it, I went to the point where I said, I probably, like this one and the very last part of the last question, I didn't show you guys how to do those. I never showed you. And like, I immediately felt guilty. Like, I tested them on something that I really didn't show them how to do. And I thought, but I have no idea what the AP test is going to look like either. There's going to be stuff on there that's right on the edge where you've got to put a bunch of skills together. That's kind of what this is. That's kind of what that last one is. So, again, I don't hate it from the AP's perspective, but I hate it from the dual enrollment perspective. Right? You see that? So, that's the way I would work this one, is the way I just explained. Maybe that makes a little sense.
Because, like, if it's imaginary number, it has to be negative and positive.
Okay?
So, but after that.
Okay, so you knew it was B or D because there was only one real root. That's correct. So that kind of narrows it down, hopefully. You could go B or D there. How to find them is we would have to find a depressed polynomial. Because we know one of the roots, we can use synthetic division to get a depressed polynomial that's degree 2. And I know how to find all of the roots when it's degree 2. Because I can factor, I can quadratic formula, I can complete the square, which I didn't show you guys. It's another story.
I watched the video.
Yeah, well, I'm going to show you how to do it today or tomorrow, because if you take the Northeast test, there is one completing the square question on it. So I'm going to show you. Bring down the 1. Can I do this part without explaining it, or do I need to explain how to do synthetic again? 1 times 2 is 2. Combine, multiply, combine, multiply, combine. The problem is I can't do both at once. That's why I'm not explaining, because my brain doesn't let me do it. So this, what's left over, this is the constant, x to the first, x to the second. So my depressed polynomial is x squared minus 2x plus 2. You following where I'm getting that from? Are you?
Yeah.
Okay. Now then, to find my other 2 roots, so I found one of them, it's at 2. To find the other 2 roots, I either need to factor this or use the quadratic formula. So if I try to factor, what multiplies to be 2 but combined is -2, it doesn't work. I can't factor it. So I have to use the quadratic formula. That's the only option I have. So quadratic formula, and I saw a lot of people did the quadratic formula.
Yeah, I did it.
And
I simplified it.
Wrong. Yes. So it's -b, so that's +2, plus or minus the square root of -2. squared minus 4 times a times c all over 2a. And so this is 2 plus or minus the square root of 4 minus 8 over 2. Everybody's okay with me to here? I just had to, I squared, I multiplied. Okay, and then 4 minus 8 is negative 4. So I've got the square root of negative 4 over 2. Well, the square root of negative 4 is 2i. 2 plus or minus 2i over 2. And here's the part where most people messed up.
Yeah, I just thought, the twos disappeared. I didn't make them ones. I just made them disappear.
So for me, if I ever have a monomial like this, the way that, like I used to make that mistake, the way I got out of making that mistake is I always broke it apart over this monomial. So write it as 2 over 2 plus or minus 2i over 2. You can break it apart that way, and that'll help you see 2 over 2 is 1. 2 over 2 is 1i, which is I. So it's 1 plus I and 1 minus I are the other two roots. Which would I get there from D?
Yeah, I was so mad at myself when I pointed that out.
Yeah. That's what most people put was B. They missed that one. Looks like that. The hard part is I know you guys are not used to simplifying this stuff without a calculator. You're so dependent on that calculator. Nope. So if something is in factored form, you have to distribute it out to get it in standard form to find the degree. Well, I don't want to distribute all of this junk out. That would be a disaster. That'd take forever. So I can just look at the powers of 4. So all of these will give me x to the 4th in total. This one will be an x to the 3rd. When I multiply those, that's x to the 7th. And then x squared multiplied by that is an x to the 9th. So this function is a degree 9 polynomial. That's the highest power term. And that's all I care about as far as power. I also care about the leading coefficient. All of these are 1, except that negative 3 at the very beginning. So when I distribute that negative 3, it stays. So now then I know odd power, opposite in behavior, negative leading coefficient, means it's going to be decreasing throughout the life of it. So that's my end behavior. So as x goes to negative infinity, we go to positive infinity. So that's either C or D. And then as x goes to positive infinity, y goes to negative infinity. Should be D. So these are the only characteristics I know about my graph. The limit as x approaches negative infinity of f of x goes to infinity. So I'm going to draw that on my graph. So what's that saying? As x's get small, y's get big. That's the end behavior. And this says as the x's get big, y's get big. So what do I know right now? Agreeing in behavior. It must be an even degreed polynomial. It's not A, it's not D. From the get-go. Everybody follows that? What I'm thinking? Okay. The second one, it has 3 turning points. So all that tells me, if it has 3 turning points, it must be at least a degree 4 polynomial. Didn't help. That one was useless. The y-intercept is at negative 12. The y-intercept is the last value. This one is negative 12. This one is positive 12. Let's see. If you went the other way, like if you did this one first, then you could have gotten down to C or D. They're the ones that have negative 12. And you could have guessed from there. So, I mean, if you just know one or the other, you get yourself to a 50-50 chance. So here, if I had to do this one, we're looking at a function from 0 to 6, and we want to know which of these could be the values of the instantaneous rates of change of the values. So all that we really got to do is draw tangent lines and figure out the slopes of tangent lines. The one point that they've given me here is 3, 2. What's the slope of the tangent line there? 0. So at 3, the slope has to be 0. Just from that, I'm 50-50. So again, this goes to where if you know the material, you can eliminate stuff. Yep.
Instantaneous rate of changes.
Slope of a tangent line. The same thing. Because this is happening at one point. So then, if I'm looking, what's happening here? 0 and 2. This one says the slope should be negative. This one says the slope should be positive. Well, over here, the lines are decreasing, so it should be negative. What's that? For me, synthetic is my last resort. I want to factor if I can, and if I can't, use synthetic. If I can't factor, then use synthetic. This factors.
Could you group them?
Yes. If there's 4 terms, you should always try to factor by grouping first. And grouping will work this time. You guys know how to factor by grouping? So the first parentheses, what's the GCF? X squared. That leaves me with x plus 2. If I factor out an x squared. The second set of parentheses has a GCF of 4. That leaves me with, it's negative 4, isn't it? Yep.
Yeah.
Sorry, I blocked out that sign. Negative 4, which leaves me with x plus 2. The parentheses match. That's how you know if factor by grouping works. The parentheses have to match. They do, which means this factors to be what's in front of the parentheses times the matching parentheses. Now this first one factors again. It's the difference of perfect squares. So that will factor to be x plus 2 times x minus 2. And then this x plus 2. So really I have x plus 2 happening twice. So it's degree 2. And then x minus 2 happening once. That's the final factored form. So my x-intercepts are at, think about solving, negative 2 and positive 2. At negative 2 would have a multiplicity of 2, which means it would bounce. This one would cross. Positive. See, I'm doing more, but I want you to see how it all ties together. It's odd powered, opposite in behavior, positive leading coefficient. We're up at negative 2, it bounces. At 2, it crosses.
Cross it negative.
Did I do it backwards?
No, because it has to cross negative 8.
Yeah, the y-intercept. Yeah, I didn't think about that. Y-intercept is negative 8, which again makes sense in terms of where I've got that bouncing at. So again, I did a little bit more than you needed to know, but you should be able to do that every time. That's the standard. Okay, so I'm going to work this one, but I'm going to have to use graphing calculator on parts of it. So let me get that situated. That way I can pull it up here and I can record it because I know the other group's going to want to see it. So the first part, most of you did okay on it. So make a two-dimensional drawing of the box, in the box, to the right. So again, that's, I'm just going to use the box as the box. I mean, whatever. So I've got a box. It's 48 inches total. About 24 inches total. I'm cutting sides off that are X long. And they're all squares. So this is what we was looking for in the first part. Questions on A? Like I said, most of you were okay on A. Find an equation that models the volume of the box. So this is the one I can't... it's hard to explain it, but you should know how it worked because we did one like it. if you cut a box and cut these corners, if I cut here and here, when I fold it, this side folds up. Like, you with me? We're going to fold it right here. And this part becomes the height. And that height is X high. It's hard for me to draw it. You have to visualize it. They did a really good job in their drawing. I can't draw cubes. Okay, but I fold it along this crease. And so this flat becomes the height, which is X high. And then same here. If I fold this one along here, its height is X high. So the height of the whole thing is X. And then, so volume is length times width times height. Here, though, we know the height is X. The length used to be 48, but I cut off an X and another X. So the length is 48 minus 2 X's. Anybody okay with where that comes from? And the width would be 24 minus 2X. That's the answer they wanted on B part. X times 48 minus 2X times 24 minus 2X. Questions? So if you think about this equation, it has two unknowns. What does each of the unknowns represent? Well, X, what does the X represent in this problem? It's the height, but it's also how much of the box I'm cutting off, right? What's the dimensions of the square? So dimensions of the square. And then the other variable is V, which is the volume. So when I graph this, the y-axis represents the volume. You follow me? You got to put the variables in their spot. Y values are the area. The x values are how much of the box am I cutting off. So if I'm wanting to maximize volume, I'm wanting to find the highest possible y value on the graph. Okay, so if you're watching, I'm going to my graphing calculator. It's loading. Okay, so I'm on my y equals screen. I'm going to use my equation. X times 48 minus 2x times 24 minus 2x. That's what I'm wanting to graph. Okay, if I graph that, that looks like it's not giving me a lot of help. So what do you think we need to work on? I think we need to work on the window. So think about it. What do the x's represent? How much of the box I'm cutting off? So what's the lowest x that makes any sense? Can you cut off negative parts of a box? So that x values being negative makes no sense. So let's put that at 0. Okay, what's the most I could cut off of the box that would still make sense? Well, think about the length and the width. The width was 24. Okay, if I cut 12 off of each side of that, that side's gone. Do you follow me? If I cut 12 from each side, if x is 12, then that whole side is missing. So x can't be bigger than 12. Doesn't make any sense if it is. And now here's just kind of a guess. The y's are talking about volume. I know I'm not going to have a negative volume. But now what's the max volume? I'm just guessing. I literally am just guessing. 1,000. If I don't like it, I'll change it. I need more. You see that? Doesn't go high enough. Window. Okay. I'm going to go to 10,000. There may be a different window that works, but this works for me. Right? And I can think about it in context. This is the volume. Y's are volume. X is how much of the box I'm cutting off. If I want to maximize it, how can we find the maximum of this parabola? We can go to second calc. We can find the max between the goalpost. So again, we can either tab over, or I'm just going to put in. It's somewhere between 0 and 24. It's 0 and 12, isn't it? Sorry. 0 and 12. Where's the max? I don't care. You can guess wherever. There it is. So the max, I'm going to take a picture of this so you can kind of see if your graph looks like my graph if you're watching on the video. Here's what I got. So x should be 5.072. Here's another thing that we didn't do a good job of, and I tried to make notes, and some of us didn't. 3 decimal places. Round to 3 decimal places every single time. I wasn't super picky on it this time. Right? I tried to make notes when I noticed it. 3 decimal places. And now then, what's the maximum volume? It would be 2,660.43. Because there's no number after it, 430. Questions on the C part? None of these I feel bad about if you missed. We did every bit of this in class. Right? Some of it was me on a video, but finding this max we did when I was here. Trying to show you how to do that on a calculator. And changing windows and what makes sense. Now the next one, I haven't shown you. Just straight up, I haven't shown you. What does x have to be if the volume was 700? So what you can think about is, in that equation, plugging in 700 for y. For v, right? Volume. So this is 700 equals x times 48 minus 2x times 24 minus 2x. If you wanted to, you could distribute and get everything to one side and then graph. That's a lot of work though. But do you see that process that I'm going through there? And then you would look for the x-intercepts that make sense. There would only be a few that make sense. Because I think one of the x-intercepts would be negative, but x couldn't be negative. Here's the better way to do it. Okay? Watch. This is so easy. Once you know this, I'm going to go back to my y equals. What do I want y to equal? You following? The volume 700, I want y to be 700. And so what am I looking for? I'm looking for the points where the red line intersects the blue curve. Because right here is a y value of 700 in red. And where does it intersect with the blue graph? Let me show you how you can do that. Again, I haven't shown you this. That's why, again, I kind of feel bad. Kind of. Second calc, I can look for where they intersect. So it says choose the first curve. So I'm just going to go over here to about where it's at in the blue line. Looks good. It says choose the second curve. Make sure it's on the red one. It is. I'm about where it intersects. We're good. Give a guess here. So there's the intersection. So again, I know if you're watching this on the video, probably not the best way to do this one. Here's what the graph should look like though. Hopefully you followed my audio instructions so you can see this graph. So the first intersection that makes sense is if the x value is 0.661. But is that the only value that makes sense? No, there's another intersection. There's two places that the volume is 700. So let's find the other one over here. So we run it again. Second, calc, intersect. Choose the first curve. Make sure it's the blue one. I'm on the blue one, so we're good. I'm just going to get over here close to where it's at. Good. Next one, make sure you're on the red one. And it is. And then guess about where it's at. There it is. The other x value is 10.772. And one thing that I haven't done either time, put your units. So these answers should be inches. And the volume one should be inches cubed. Right? Cubic inches. So what I'm going to do as the replacement for this, if you're going to do the Northeast test, to get the Northeast grade, it's going to be the Module 3 test. There's a practice test on there that you can work on. You can take as many times as you want. I think there's a 20 limit. If you take it more than 20 times, I'll fix it. I can make it bigger. All right, I can change that number. So take that practice test before you take the actual test. But we don't need to wait around because we're going to be learning new stuff tomorrow. So I'd like to try to make a rule that it needs to be done within a week of the other test. So if we could get it done by Wednesday next week, the test, does that seem reasonable to everyone if they're going to retake that? So let's say that this needs to be done by Wednesday, September 27th. Like I said, I looked at the test yesterday. There's a couple of things on there that we haven't covered. Just two that I noticed. One of them was completing the square is on the test. And I'll show you how to do that very quickly. One of them was graphs of parabolas with inequalities. So do you guys want me to show you that part, or do you guys have another question on this? So let me square first, because I can make one of those up pretty easily. If f of x was equal to x squared minus 6x plus 20. So it actually says, it doesn't say complete the square, it says put it in vertex form. Well, we know what vertex form is. X minus h squared plus k. Or x minus x. We used h, didn't we, when we did that earlier? I think I used h and k. So it has to factor to be the same thing in parentheses both times, which is what completing the square does, is it gives you the same thing in parentheses. So that's the way we're going to do it. To complete the square, you need to make sure your leading coefficient is 1. If it's not 1, you must divide everything by that number. So I gave us an easy one here because the leading coefficient is 1. That's step 1. Step 2, take your B term, half it. So this is in our heads. Half this number, -3. Square it, +9. Okay, that means we need to add 9 to both sides. So this is f of x. I'm going to add 9 over there. This is the way I teach it. There's different ways you can do it. Equals x squared minus 6x plus 9 plus 20. Now these three form a perfect square trinomial. Can you guys look at that and know what that factors to be without me doing A times C method? X minus 3 times x minus 3. So the parentheses matched. So we could write that as x minus 3 squared. Is everybody okay with that? I know I'm kind of doing that quickly. Okay, then the only other thing you need to do then is move this 9 over to the other side. Get f of x back by itself. So if I add 9, or if I get rid of the adding 9 to the other side, it becomes a -9. You guys okay with that? Or you could think of subtracting 9 both sides. Hopefully we can do the other way. So that would be 20 minus 9, which is 11. I'm in vertex form. X minus h squared plus k. You have to complete the square to do that. There's one like that on the practice test. So again, steps. Your leading coefficient, A, must be 1. If it's not, divide everything by that A. Then look at your B term, and in our heads, half it, square it. Add that to both sides. Complete the square, or factor those three. Go from there. These are weird, and I may not have time. But they're easy with a calculator. So this is a quadratic. X squared plus 15x is greater than 90. Okay, if you think about trying to solve this, it'd be hard to solve it algebraically. Because, what, you got a GCF of x. X times x plus 15 is greater than 90. But that doesn't get me anywhere, okay? So we can't solve quadratics with an inequality algebraically. We must do it graphically. So here's how you do it graphically. Get everything to one side. X squared plus 15x minus 90 must be greater than 0. So what am I saying? Where is the parabola above the x-axis? Where's the parabola positive? You understand that question? The parabola is on the left. Greater than 0 means it's above the x-axis. It could be less than 0, which means it needs to be below the x-axis. It could be greater than or equal, less than or equal to. All you have to do, put this in your graphing calculator. Look at the interval. Where's it above the x-axis? So I'm just making this up. I don't know what this one looks like, but I know it opens up. I don't know if it has x-intercepts or not. Let's say it looks something like that. Well, it would be above 0 from negative infinity up to this point. I'm going to call it -5. Right? All of this is greater than 0. And all of this is greater than 0. Above the x-axis. So then you'd have to do union. And then say that that x-intercept's at 4. It's positive infinity. That's the way you solve those. I've got another one of those videos that I made that I sent to Trey Rutledge because he asked me, because he worked a Canvas problem. So I worked one of these out that had real good numbers. I'll share it too. That way you don't have to just see this where I made it up and I don't know exactly where they are. You can try one that I know will work.